Good evening, students. Guys, how are you?
Good evening, sir.
How are you guys? I'm Sunil, Nitish.
Fine, sir. How are you?
Yeah, fine, good. ఏం కావాలి? Guys, shall we start the session? Why very less count today? Yes, only 8 members out of many.
Sir, we are having exams, sir. Maybe because of that.
Okay, we'll start. Anyway, sir will record the sessions and he will upload. So, last class, what we are discussing? We are discussing about the different functions and their graphs. Am I right? Correct? Range and domain of those functions. Am I right, guys? Students,
Yes,
please.
sir.
So today we are going to discuss piecewise functions. Piecewise functions. It's very simple to understand piecewise functions. Diagrammatically, the graph is not a single graph and not an uniform graph. It will comes into different parts, pieces. It might be more than 2 pieces. The graph is in theoretically how we can define this function is a piecewise is a function of a multiple subfunction. It is defined a piecewise, name itself, it's a piece. A piecewise function defined function is a defined by, sorry guys, the function defined by multiple subfunctions. The function is split into many functions and each subfunction is defined through its domain and range, where each subfunction applies to different intervals in the domain. When I'm reading little bit interesting and difficult theoretically, but if I'm going with some examples, it will be easy to understand. Suppose if I'm saying f of x is equals x square when x is less than 0 to 0 less than x less than or equal to 2 minus x minus 2 whole square plus 4 for x greater than 2. So if I am explaining a function like this is also a function, but this function is combination of three different functions. And if f of x, where x is some minus 2, minus 3, which is less than 0, my function f of x is x square. And between 0 and 2, the function is 2. It's a constant function. Say, and between x greater than 2, it is a quadratic equation. It's also a quadratic equation. So if I'm trying to draw the graph for this, it will be easy to understand. It will come like different pieces. So out of this, we can explain the continuous and discontinuity again. So for all negative values of x, this is 0, minus, negative, and this is positive. All negative values of x, the function is a quadratic equation. At 0, the function is not at all defining anything. That's the reason at 0, there is no value for the function. And again at 0 to 2, the function is like this. And again from 2 to 2, any infinity. That means from 2 to any value. For all positive value, the function is minus of x minus 2 whole square plus 4. This will use x square plus 4 minus 4x plus 4. So this will use minus x square minus 4 plus 4x minus 4 plus 4. So this will be x square minus x square plus 4x graph. How the minus x square plus 4x graph looks? See this one. But my function is defining from 2 only. My function is defining from 2 only. So my graph is coming like this. This is 2. From 2 will be like this. This is the f of x graph in this case. This is the domain. The domain is split into 2, 3 parts, 4 parts, might be many. Maximum will deal with 2 pieces, 3 pieces maximum. So if any function is defined in such a way, parts of the subfunction and each subfunction is defining an interval, then these functions are called piecewise functions. Guys, are you clear what I'm saying? Guys, clear what I'm saying? Students, please understood what is meant by piecewise functions? Raghav.
Sir, can you repeat, sir?
See, if any function is defined as parts of subfunctions, this is one function, this is another function, this is another function. Each subfunction is having particular interval. All the intervals is the domain of the f of x. Then that function is called piecewise functions. So this function is explaining in the different pieces. And if you look into the graph is not like a uniform or not like a standard graph. Sometimes it is a curve, sometimes it is a straight line, sometimes it is a different. So if any function is in the form of subfunctions and each subfunction is defined in each different intervals, then that function is called piecewise function. Got it now?
Yes, sir.
And this piecewise function may be continuous, may not continuous. The meaning of continuous means, see this graph. At 0, there is a break. At 0, there is a break. The function is can't be defined at 0. The domain of this function is r minus 0. You have to exclude 0. Rest of all the values is the domain. So if any function is having undefined values in between minus infinity to infinity, that is called discontinuous functions. The graph is not a continuous. There is a break in between. Understand what is the meaning of discontinuous function?
Yes, sir.
So continuous functions are like this. Sorry. Continuous functions are like this. See, this is a continuous function. Suppose if I am taking a linear graph is a continuous function. Suppose if I am taking y is equal to 4x, this is a continuous function. Suppose if I am taking y is equal to x square plus 3x plus 4. This is a continuous graph. See, if I am zooming out also, you will get a continuous graph. There is no break from minus infinity to plus infinity. The graph is continuous. But if I am taking a graph like this, I will tell you name of some standard piecewise functions also we are going to discuss today. Domain and range of the standard piecewise function. Y is equal to mod x by x. See this graph. You can, if you observe this graph, there is a discontinuity. See here. So this is like a piecewise function. At 0, what is the value of x? You can't define it properly. At 0, actually it is 0. This is also one kind of piecewise function. And we can say discontinuity and continuity of the graph. Suppose if I am taking a graph, greatest integer function, which will be available in the textbook. This is modulus function, this is sine function, this is called great DAF function. This graph shows the greatest integer function. See here, the graph is looking like in so many pieces. This is also a discontinuous function. So without drawing the graph also, you have to understand whether a function is continuous or discontinuous. We will discuss in plus 2. In plus 2, the name of the topic itself, continuity. Using the differentiation concept, we will discuss whether a function is continuous or discontinuous. If it is discontinuous, where it is discontinuous. We will discuss how to identify the discontinuity of a function if exists. Using the differentiation, we will discuss in plus 2. But as of now, at least we have to know what is meant by continuous, what is meant by discontinuous. At least that is enough. These kind of different functions, we are having 3 standard functions. One is modulus function. Everybody knows modulus function. How it is what is meant by modulus function? How we can consider f of x is the piecewise function. Actually, mod x means what? Anyone can know what is meant by modulus function? What is its meaning?
Sir, it's an mathematical operator which will turn out the value into positive. It will
That
do
is
that.
little bit computer point of view, correct?
Yes, sir.
Whatever the x value, y is always positive, correct? And equal to x. Magnitude, value of the point of view equal to x, correct?
Yes, sir.
If x is equal plus 1 also, y is equal plus 1. If x is equal minus 1 also, y is equal plus 1. If x is equal minus
Sir,
1.
I guess you are writing it. Like, y should be minus 1, sir, not
How
x.
y should be minus? No, y never negative. Y is modulus of x. What is the meaning of modulus of y is equal to magnitude of x? That means y is always positive. Why can't be negative? Your f of x is mod x. What is f of x is mod x? Your input may be anything, but output is always only the value of x. Am I right?
Okay, sir.
Got it? What I'm saying?
Yes, sir.
So y is equal plus 1.5. If x is equal to 1.5, y is also plus 1.5. Actually, how this function is defined? What is x? Let's see, mod x is a symbol from where we are defining this function as a single statement. Actually, mod x, if I am splitting into pieces, mod x is actually like this: minus x for x less than 0, 0 for x is equal to 0, plus x for x greater than 0. Instead of writing like pieces, I can represent with a symbol. This piecewise function can be represented as mod x. Why mod x? I will tell you. The mod x is defined with some statement. Mod x means only you have to consider the magnitude. Whatever the input, it will use only magnitude of the x value. Sign does not affect the function. That is the meaning of modulus as of now. Correct? Am I right, guys?
Yes, sir.
What mod x says, if x is negative, your f of x is minus x. Substitute any negative values, what you will get here? Substitute any negative values of x, what is your f of x value? Substitute any negative values. Suppose if x is equal to minus 2, if x is equal to minus 3, if x is equal to minus 4, what is your f of x values correspondingly? Tell me, guys, please, quickly. Amsini, what are the f of x values? If I am substituting minus 2 in this, it will be plus 2. If I am substituting
Plus
minus 3, plus 3.
3. Plus
If
3.
I am substituting minus 4, plus
Plus
4.
4.
It is a piecewise function. This function is defined up to negative values minus x. If it is 0, the function is 0. If it is positive, the function is plus x. That means if x is equal to 1, your f of x should be x. If x is any positive value, your f of x is x. The function is not a single statement throughout its domain. The domain of the function is minus infinity to infinity, but this domain is split into different intervals. From minus infinity to 0, it is defined as minus x. At 0, it is defined as 0. At 0 to infinity, it is defined as plus x. So three different intervals, three different statements. Together, I am writing as a symbol because it's a one kind of standard function for me. So this is actual definition of modulus function. Is it clear, guys, what I'm saying?
Sir, I have a doubt, sir.
Yes.
Sir, if x is negative, f of x will be plus x, right?
Minus x. How plus x? Suppose if x is negative, f of x is plus x. I am taking your statement. But it is not giving the modulus function. No? If x is negative, you are saying f of x is minus x. Substitute any negative value, what you will get f of x value? F of x is plus x, you are saying, sorry. Substitute any negative value, what is your f of x? What you are getting?
Minus 2.
Minus.
It
But
yes,
actually, what is the modulus function says?
it will give positive value.
Should be positive, correct?
Yes, sir.
So, if x is negative, minus x. If x is positive, plus x. If x is 0, f of x is also 0. So, it is behaving as a linear function, a constant function, again a linear function. So, if I am taking a graph for modulus function, this is a graph of the modulus function. This is a graph of the modulus function. See here, it comes like a two straight lines. There is no value defined for negative region of the y. That means range doesn't have any negative values. Its domain might be plus infinity to minus infinity, and there is a continuity. It's not a discontinuous function here, but its range is only from, guys, what is the range value here?
0 to infinity.
Yes. Can I say domain is what here? Domain of modulus of x is R value.
All real numbers.
Range value is only R plus. Will you agree with me, everyone? Guys?
Yes, sir.
Guys, will you agree with me, everyone?
Sir, should we write R plus or infinite 0 to infinity in exam?
Both are same. Both are same. This is minus infinity to infinity. This interval form is 0 to infinity, closed interval.
Fine, sir.
Both are same. R plus. Yeah, is it clear, guys? One more standard function that doesn't have any name. F of x is equal to minus of mod x. How we will define this function? F of x is equal to minus of mod x. If I am looking into the graph of this function, I will get like this. This is the orange color graph shows the y is equal to minus mod x. How we will define this function? What is it piecewise form? Anyone can give the piecewise form of this function? What is it meaning? Whether x is positive or negative, f of x is always
Negative.
negative. So how we will deal this one? I can write like this. Everyone can agree with me or not, please. Little important for your +2 guys. Don't think it is not much important. F of x, actually this is in the form of piecewise. Minus x, sorry, plus x for x less than 0, 0 for x is equal to 0, minus x for x greater than 0. Now substitute any value, you will get always your f of x is negative of x. Am I right or wrong, guys? Your domain is or range is r minus infinity to infinity, range is minus infinity to 0. Anyone having any doubt? I can't say it is a modulus function, negative of modulus. Modulus is irrespective of sign. If you keep negative positive, always it is giving the magnitude of the x. But here, negative magnitude of the x always it will give. Yes, please.
Sir, why have you put 0 as closed interval?
Yeah, if you substitute 0, it is giving 0 now. 0 I can't exclude. Am I right? It is a part of the range.
Sir, but then it is neither positive nor negative.
Yeah, correct. Oh, sorry. I can understand. Negative of x. Negative of x is 0, doesn't have any sign. As you said, I have to exclude this one. We can't say neither positive nor negative. 0 can be considered as both negative numbers and positive numbers. Is there any sign I can define for 0?
No, sir.
Yeah, I can exclude this interval from the range. So the domain also r minus 0 I can say then. So this is also one more function we can define where it's graph like this. Shall I go for the next one? Guys, I can go for next one. Yeah, next one is called sine function. Generally, some people will call signum function. The sine function will give, it's a constant function and it is also a piecewise function. F of x is mod x by x. What is its meaning? For all negative values, actually this is a function of minus 1 for x less than 0, 0 for x is equal to 0, sorry, plus 1 for x greater than 0. What it means? Anyone can explain from this function? Guys, please, from this statement.
So we can say that the range is always -1 to +1.
Yeah, and any other information can you identify from the function? This function will use only the sign, whether it is +1 or -1. It doesn't give anything, correct? It is also a piecewise function. It is also a piecewise function. Yeah, you have to give 0 also. If it is 0 for x is equal to 0, that means if it is 0 where I can't consider anything, straight away f of x is a constant function. Instead of representing in 3 function, I can represent this one. That means if x is negative, my f of x is -1. If x is positive, my f of x is +1. If x is 0, f of x is also 0. But x is equal to 0, substitution will not explain this expression, but rest of the expressions will give. Suppose if I am substituting, I am taking f of x is equal to mod x by x. If I am taking x is equal to -2 and substitute here, what is your value? F of x should come -1. You substitute any negative value, your f of x should be always -1. Check whether you are getting or not. Anywhere it is failing. Guys, please. So domain is what? I can say R. Range is what? Anyone can explain the range here? What is the range? Yeah, please.
The closed interval -1, 0, +1.
Yeah, it's not interval. How? Is there any value?
Yeah.
If I'm saying -1 comma +1, are you getting any answer 0.9? For any x value, are you getting 0.9? No.
No, sir. Okay.
Is -1 comma.
Okay.
You take any value, your answer should be, for all negative values, the answer is always -1. For all positive values, the answer is always +1. Suppose if I'm taking x is equal to 0.9. So my f of x is modulus of 0.9 by 0.9. So this is +1. If I'm taking x is equal to -0.8. F of x is minus modulus of 0.8 is by -0.8. This will be +0.8 by -0.8. The answer is -1. Understood, guys? What is the range and domain of this sine function?
Yes.
So suddenly, if you they will give these functions, you should not confuse. Other than these standard functions, they will give the range and domain. If they are giving the standard function, they won't explain the range and domain. Yeah, the last one is greatest integer function. Greatest integer function. Generally, we will call as GIF function. GIF function. It's called greatest integer function. What is this greatest integer function says? It is always close to its greatest integer. Whether it is a fraction, whether it is a rational or rational, it is always the value of output always close to its integer. So a function f of f is defined on R to R. Your set A is also real number, set B is also real numbers. So the greatest integer function will define like this. And if I'm saying my f of x is equal to, keeping into closed braces, this symbol is called greatest integer function. If any function keeping into braces like this, then it says greatest integer function. What is this greatest integer function? This function is having many pieces. f of x can be written as -1 for -1 less than x less than 0. 0 for 0 less than x less than 1. +1 for 1 less than x less than or equal to x less than 2. +2 for 2 less than x less than 3. +3 for 3 less than x less than 4. Like this, you can write infinity intervals. This function is defined as infinity constant functions with infinity intervals. Understood, guys? What is exact meaning? Anyone can tell with some examples. What is meant by actually greatest integer function with some x values? Suppose if I am taking my x is equal to 1.52, my f of x is 1. If I am taking x is equal to 1.59, my f of x is equal to 1. If x is equal to 1.99, my f of x is 1. If x is equal to 1.00001, f of x is 1. But if x is equal to 1 also, that is nothing but 1.00, f of x is 1. If x is 0.999, my f of x is 0. Even it is 0.0001, my f of x is 0. What is its meaning, guys? What is its meaning? Why I am calling this is the greatest integer function? Guys, anyone?
So whatever input we give, we write the answer as an integer.
Integral part of the value. Understand what I'm saying? See, this part is called decimal part. This is called integral part. So on the number line, nearer to 0, which is your integral part, greatest integer from 0 to that number, greatest integer from 0 to that number, that part you are going to consider here. Is it clear what I'm saying, guys?
Yes, sir.
Suppose if I'm taking 1.001 from 0 to 1.001, what is the greatest integer? 1. From 0 to 1.999, the greatest integer is 1. Is it clear, guys, what I'm saying? Anything confusion? But in case of negative values, it is slightly different. Anyone observe? Negative values, how it is defined? For negative values, from 0 to -1, if it is -1.0000, the answer is -1, not 0. See here. Up to here, the greatest is -1. Sorry, -0.0009. It is -1. If I am taking -1.001, it will be -2. Understand what is the difference between there and here? Suppose if x is equal to -1.9999, your f of x is -2. Even if it is -0.0001 also, f of x is -2, not -1, not -1 here. It's not like positive values. So always you have to come from left side. In left side, what is its greatest integer? From -infinity is like a starting point. So if I'm taking this is -1, this is -2, this is -3. If I'm taking x is equal to -1.5, somewhere here. So from -infinity to -1.5, what is its greatest integer? -2. So your f of x is -2. This is represent greatest integer function. Understood, guys? What is the meaning of greatest integer function?
Yes, sir.
So the graph of the greatest integer function is always a straight line. See here, this is a from 1 to 2, it is always plus 1. This circle says 2 should not be included. This 2 should not be included. If I'm including this 2, the graph will start from here to here. From 2 to 3, the graph is this one, where 3 is not included here. From 3 to 4, this is a graph. From 4 to 5, this is a graph. So what is your range and what is your domain? What is the range and domain of the graph? Anyone? Hamsini, can you try? What is the range is or, correct? Any x value you can substitute. Any real number you can substitute, correct? The name it is saying. What is the range? You are taking only the integral part of the x. Then your f of x is always, please guys, think for it.
Integer.
Some integer. It never a fraction. It never a irrational number. So your range is, he didn't mention range here. Your range is always integers. Your range is always integers here. Got it? What is
Yes,
the
sir.
meaning of greatest integer function? So you should not confuse. Other than this, we may face sometimes some other functions. Wherever it is repeating, there I will explain. One is called fractional function. Your f of x is looking like this. This is also one function, fractional function. I will check through online, but it is not part of our textbook. Let's see what it is saying. Fractional function. This is a fractional part of the function, means you are going to take only the fractional part. Yeah, this function says fractional part of the function. It looks like this. You have to take only the fractional value of the function. Same as least integer function is also there. This is called least integral function. Looks like always GAF function, but there is a difference between least integer function and greatest integer function. This is a least integer function graph. These two graphs, if it comes in your syllabus, then we will discuss, otherwise not required. But what are the graphs we are discussing, that is little important for, even though if they are not giving the range and domain, you have to understand at what are the x values the function is defining. All these x values are defining at all real numbers. A few functions are not defining at 0, but when it comes to range, different functions is having different ranges. Next, we are going to discuss algebra of the functions. What is meant by algebra? Algebra function means, we know if I'm having numbers, I can add, I can subtract, I can divide, and I can multiply. Same as if I'm having two functions. If I'm having f of x and g of x. Suppose if I'm having f of x, it is very simple to understand. Something I am defining on f. F is a function which is defining from x to r, and g is a function which is defining from x to r. If you look into this, the domain and range of the functions of f and g both are same. If I am adding these two functions, and it is defined from x to r only. That means if f of x is x square, and it can be defined from r to r. If g of x is defined some x plus 2, this also defined r to r. If I'm adding these two functions, I will get a new function, f of f plus g of x. This function is also defined from r to r only. X must be a subset of r. X must be a subset of r. So this is called algebra, addition of two real numbers, two real functions. Subtraction, same. If f is one function, g is another function defining on x to r, where x is the subset of r. My subtraction function is also defined from x to r only. Same as multiplication and division. F is one function and alpha is a scalar, and if I am multiplying f with some constant, your x belongs to always capital X. Multiplication of two functions here, same way. If I am multiplying two functions, if x is one function, x square is function. If I am multiplying, I am getting x cubed. If x is defining from x to r, x square is also defining from x to r, x cube also will define from x to r only. So quotient function also same, where g of x, the quotient fraction should not be 0. Generally, these functions are called fractional function. So these algebra rules will be useful to define the combination of two functions. If I am giving the two functions, if I am asking what is the range and domain, these points will be important for us. Here also same, f is defined x to r and g is defined from x to r. So f by g is also defined from x to r, where g of x should not be 0. That denominator should never 0. So it looks very easy. Only for a higher level point of view, these points will be discussed a little bit elaboratively. Suppose if I am giving two real functions, if I am adding two functions, means just we have to add both the functions. Just we have to add both the functions. Subtraction function, multiplication of two functions, and division of two functions. See here, if I am taking this question, for example, first we have to check the given functions are real functions or not. Yes, the given functions are real functions or not. F of x is x square. It's a real valued function because f of x is x square means its range. It is a range. Domain is R. Range is also R. And another g of x is 2x plus 1, and its domain is capital R and range is also R. So g of x also defined from R to R, f of x also defined from R to R. So from here, if I am asking what is f of f plus g of x, just add both the functions, x square plus 2x plus 1. F minus g of x, you are subtracting the two functions, x square minus 2x minus 1. F into g of x, this will be 2x cube plus x square. F by g of x, this will be x square by 2x plus 1. This is called algebra function. Is it clear, guys, what I'm saying? Now onwards, whenever you are getting algebra of differentiation, algebra of continuity, algebra of calculus, you are getting this. If I am doing in addition, is there any changes? Whether I can do add directly, or is there any different way I have to do? Addition can do like numbers or not. That will explain the algebra of that particular quantity. Suppose if I am taking differentiation, algebra of differentiation means we will discuss there. But I'm saying algebra of differentiation means if I'm doing the differentiation of a function, but if I'm adding two functions, whether I can do differentiate directly or I have to use any principles. Sometimes division and multiplication won't work like numbers, but functions are not like that. Straight away, like numbers, how we are adding, subtracting, dividing and multiplying, you can do like that. So shall I go for some exercise numericals, guys?
Sir, I have a doubt, sir.
Yes, please.
So can you show that slide?
Yes, this one. This one.
No, sir. Yeah, here the range of x square should be r plus, right?
Yeah, the range is r plus, correct. It's not r, range is r plus. It's always positive. Correct.
Fine, sir.
Sir,
Yes.
sir, why it is R plus, sir?
Sorry.
Sir, why it is R plus?
He's talking about range is f of x is x square. We already discussed now. Domain is what?
Okay, sir.
Anything
Domain is real
range
number.
is what? Only positive real numbers, correct?
Yes, sir. Sir, but for g of x?
Yeah, domain range might be anything, but it is defining on, but f of x is defined on R to R only, no? This is not range, this is codomain. Here codomain is R.
No, sir, it is given like g of x is equal to 2x plus 1, I think so, sir.
Yes. 2x plus 1. What is the domain here?
R.
Range?
Range will be R.
R only. You take any y value, any g of x value, corresponding x value I can show.
Sir, but then f of x is R plus and the g of x is only R. So
That's
f of
only range. This is only range. Here also codomain is R only, no?
Okay, sir.
See, f of x defining R to R, where f of x is x square. What is the wrong in this?
sir, so R to R means from domain to codomain.
Yes, it never
Okay.
this never gives range. This is only codomain.
Okay, sir.
This is only codomain. All the it is that's what we discussed now in the beginning. You are defining from this set to this set. I don't know whether all the values of the second set can be part of the range or not. That is depends upon the f of x. When you will call real valued function means you are defining from R to R, then it is called real valued function. Yeah, see this one. They gave root x, they gave x, they are asking f plus x, root x plus x, root x minus x, root x into x, root x by x. This is called algebra function. So we are moving to some questions related to functions. Look at these questions. Yeah. Which of the following relations are functions? Give reasons. If it is a function, determine the domain and range. What is the definition of the function when they give in roster form? The first element should
The
not
first element shouldn't be repeated.
be repeated. The second element may be repeated, correct?
Yes,
Yeah. What is the first one?
it is a function.
It is a function. Why?
So the first elements aren't repeated.
Yeah. So how you will write the reason? The reason is you can show with the diagram also. Each and every element of first set having one and
Only
only
one image.
2 to 1, 5 to 1, 8 to 1, 11 to 1, 14 to 1, 17 to 1. And each and every element is a pre-image of image. So its range, its domain is what? What is the domain? 2,
2,
5,
5,
8,
8,
11,
11, 14,
15,
17,
and range is
1.
1. We can't say codomain because it is not defined on what to what. Whatever the second one?
It is a function.
2, 4, 6, 8, 10, 12, 14. It's a function. Third one? It's not a function. Why it's not a function?
1 is
1,
repeated.
3, 1, 5. 1 is having 2 images, which is violating the definition of the function. 3, 5 are the images of 1. So 1 pre-image having 2 images, so it's not a function. So no need to explain the range and domain. But when it comes to second question, what is the domain? 2, 4, 6, 8, 10, 12, 14. When it comes to range, what is the range? 1, 2, 3, 4, 5, 6, 7.
So what is the codomain in this?
Codomain can't be explained here. Codomain means they have to explain the function is defining from what set to another set. Then only you can explain the codomain.
Okay.
Sir, can we also write the reason as all the pre-images as an unique?
Super, correct. All the pre-images is having a unique image. Anything, because we defined the first element is calling as pre-image, second element is calling as image of the first element. So we can define in that way also. Okay. Next one. Yeah. We already discussed how to explain the domain and range of the following function. F of x is minus modulus of x. What is its domain?
All real numbers.
All real numbers. Range?
Minus infinity to 0.
So minus infinity to 0. Everyone will agree? Second function. If of fx is root function 9 minus x square, what is its domain? Any x value will be suitable here. Is it possible any x value can able to keep it here?
No, sir.
Correct. So root under the root value is defined for what? Under the root value must be greater than 0 or equal to 0. Am I right?
Yes, sir.
Under the root value must be greater than 0 or equal to 0. That means 9 minus x square must be greater than or equal to 0. From here this can be written as 3 minus x into 3 plus x must be greater than or equal to 0. When this is possible? This is possible when both are negative or when both are positive. When both are negative or when both are positive. Correct? So from here, how we will define x value? Inequality functions from grade 9. How we can define the x value?
3 and minus 3.
Minus 3 less than or equal to x less than or equal to plus 3. Am I right? Am I right or wrong?
Yes, sir.
Yes, sir.
If you take any value less than minus 3, you will get what you will get? The whole expression will become
Negative.
if you take any value greater than 3, that also will get negative.
Negative.
So what is the domain? The x values, what are the inputs of the x values?
0 to 3.
No. No, man. X value might be from minus 3 to plus 3. How you can say 0 to 3? Why minus 2 is not suitable? Minus 1 is not suitable? Minus 3 is not suitable?
Okay, sir. I think I told the range.
No. Range is what? What is the range? What is the range of this function? Anyone? What is the range of this function?
0 to 3.
Why you won't get any negative value? You won't get any negative value? If I am substituting x is equal to 0, what is your f of x?
3 plus or minus 2 plus or minus 3.
Then what is the range? Guys, please think over it and let me know. Anyone?
So is it the same?
Sorry?
Is it the same minus 3 to 3?
See, if I'm keeping x is equal to 0, what I'm getting? F of x is root 9. Root 9 is nothing but plus or minus 3 now. Is root 9 is plus or minus 3 or only plus 3?
Plus or minus 3.
Guys, again I'm asking. Please.
Sir,
have
sorry,
to
sir.
take-
It will sorry. It will be only plus 3, sir.
Why?
Sir, only when we square we can tell like that. But here it's square root. We
I'm
don't
taking
keep-
plus or minus 3. This function is a relation. This function is not a function. Why it is a relation? If I'm substituting 0, you are saying your answer is plus 3 and your answer is minus 3. What is the definition of the function? One pre-image must have a unique image. But what is happening if I'm substituting 0 here? Please. What is happening? It's substituting 0 here.
So we are getting
Guys,
2.
please. Yeah, that's the reason root x function, when I'm defining the root x function, negative values of the x you won't consider.
Sir, but
Why
then still
in
minus
future?
3 and plus 3 are not same, right? They are different, right?
Yeah, different, but you are mapping to same different images, no? See here, what you are saying.
Okay, sir, understood, sir.
See, this is your domain, this is your range set. So if I'm taking 9 here, sorry, 0 here, and you are mapping to minus 3, and you are also mapping to plus 3.
Yes, sir, it's wrong.
So it's wrong. It's not it will become a relation. So let's see, you have to recapitulate the concept of root x function. If y is equal to root x power 0.5, I can say it is the root x. See this one. He is not defining for any negative values, even though if it is 2, if I am substituting, he is not taking, suppose if it is taking 4, he is not taking plus or minus 2. Why he is not taking plus or minus 2? Why? Root x is defined, the range of the root x is only positive real numbers. Why he is taking, we will discuss in inverse functions. As of now, the range of this function is only 0 to 3 only. Understand, guys, what I'm saying?
Yes, sir.
Yes, sir.
In inverse, by the concept of the inverse function, we will get one clarity. Why the range is never negative here. F of x is why we won't take negative. In inverse functions only we can define here. We'll get one clarity. Yes, we can argue why minus 3 comma 0 is not the range. That is also possible, no? Am I right or wrong, guys?
Sir, but then why did we take x value as 0 and now solve?
If I'm taking x is equal to 3, I will get 0. If I'm taking x is equal to minus 3 also, I'm getting 0. If I'm taking x is equal, x square is 5. The 5 is in between minus 3 comma 3. So plus or minus 2 will come. But in a range, we will take only plus 2 to define this is a function, not a relation. If I'm taking minus 3 to 3, range is minus 3 to 3, f of x will become a relation, won't be a function. So now you ask your question, please. You're asking something?
Yes, sir. Why did we take x as 0 and find the domain? Range, sorry.
It will be discussed in, actually, real valued functions can't be discussed on fractional powers. If you remember when I'm discussing in the beginning, the functions is defined only for power something. Here the given function is what? A root function. Root function means what? The power is, index is what?
1 by 2.
F of x whole square is 9 minus x square. So the f of x whole square means what? For any x value, the square of function, the square is always must be positive, no? Am I right?
Yes, sir.
That's the reason I am taking only 0 to 3. When you are defining as a relation, you can consider both. Confused?
No, sir, I understood how we got the range, but then from
Why I am not taking negative values here?
no, sir, not about that. How do you write this in steps while presenting in exam?
Oh, straight away, you can take these are the steps.
So that is for range. That is for domain. What about the range? How do I write it?
Generally, it is depends. Substitute minus 3, what you are getting, substitute plus 3, this is the starting value and this is the ending value, no? Am I right?
Okay, sir.
Like that.
Sir, if it was infinity?
Complete is logically. Infinity means it is open. At infinity, we won't define anything. It's completely depends upon your calculation strategy. There is no proper particular steps. I will
Okay,
explain
sir.
some more range and domain question, then you will get one clarity how to explain in exam. Okay?
Yeah, yes, sir.
Yeah, what is the function defined? F of x is 2x minus 5, and write down the values of f of 0. What is f of 0 here? Minus 5, correct? What is f of 7? 9. F of minus 3 is how much?
Minus 11.
Minus 11. Simple. What about the fourth question? T of C is defined by 9C by 5 plus 32. He's asking different values. So T of 0 is how much?
32.
32. T of 28? T of 28. 9 into 28 by 5 plus 32. How much? How much? 9 into 28 by 5 is how much? T of minus 10?
49.4.
49.4.
4 plus 32, sir.
Yeah, 49.4 plus 32. 81.4. Am I right? Minus 10 means minus 18 plus 32 plus 14. Am I right?
Yes, sir.
T of C is 212. How you will tell the C value? 212 9C by 5 plus 32. So 212 minus 32 is equal to 9C by 5. So how much you are getting here? 212 minus 32 is how much? 180. Yeah? Is C is 100?
Yes, sir.
Find the range of each of the following functions. See, the function is linear function. All functions are linear function. If the function is linear, what is its range, guys?
All real numbers.
All real numbers. It's very simple. This represents a straight line. This represents a straight line. This represents a straight line. So, according to our standard functions discussion, you can straight away write like this. This x belongs to or represents the domain. X is a real number, represents the domain. They gave the domain. They are asking the range. How you will explain here? The given function is a linear function. If f of x is a linear function, the range is R. If f of x is a square function, the range is R. If f of x is a cubic function, polynomial function, the range is R. Will you remember? In the book it is not given, but we discussed. Am I right? We showed with the different gaps. X power q, x power 4, x power 10, x power 90, everything we discussed. Understood, guys? Yeah, shall I wind up the session? In tomorrow class, I will start the mathematical induction, but I will explain a set of different numericals, how to explain the range and domain of that particular functions. Like we asked, somebody is asking, sir, how we can explain? It will be different. Problem to problem, it is different. You have to use the skills of algebra here. Your arithmetic and logical and reasoning. 3 skills we have to use for higher level numericals. But the thing is, board level never asking that much. It's only for entrance point of view. These functions and all, they are asking to a high range. For board level, as of now, what are the questions I expected? Simple functions, graphs, range and domain of the functions of simple functions, or they will ask you to draw the mapping diagrams. They will give one diagram, they will ask you to write the range and domain, cross product. These things only many times they ask. But entrances, that is in Tamil we can say at the very level. They will ask like that. So a few questions we will go through that kind of level. What I'm saying, guys? A few questions we'll discuss. Like in miscellaneous, you can see those kind of questions. Very few questions. See here they explain with a relation is defined. A relation is defined. So f of x is x squared. Find this value. These are all the very simple questions. When it comes here, we have to think a little bit the range and domain of these functions. And other than this, here the range and domain of these functions, how we will explain, we will discuss in next class. And if time is there, we will go for mathematical induction. Shall I went? Trigonometry. Next is trigonometry. Am I right, guys?
Yes, sir.
Yes.
Discuss trigonometry, one of the important topic. We'll meet in next class. Bye, everyone.
Thank you.
Thank you, sir.
Thank you.
Thank you.